It's wonderful to see you all. And I am delighted to introduce Dr. Carolyn Rosé for her keynote presentation. From a personal perspective, I've known Carolyn for close to 15 years, at least as best as we can figure. She's one of the great thinkers of CSCL. I've learned so much from our conversations over the years, including the broad range of CSCL issues that she thinks about and investigates. Dr. Rosé is a professor of language technologies and human-computer interaction in the School of Computer Science at Carnegie Mellon University. Her research program focuses on computational modeling of discourse to enable scientific understanding of the social and pragmatic nature of conversational interactions of all forms, and using this understanding to build intelligent computational systems for improving collaborative interactions. The goal of her research is to develop technology capable of supporting effective participation in conversation to achieve a positive impact on human learning, growth, and well-being. Her research group does highly interdisciplinary work. She's published in over 270 peer-reviewed publications, is represented in the top venues of 5 fields, namely language technologies, learning sciences, cognitive science, educational technology, and human-computer interaction. She is a star in all these fields with awards in 4 of them. As Ulrich said, she is past president of ISLS and an inaugural fellow of the Society. She's a senior member of IEEE, the founding chair of the International Alliance to Advance Learning in the Digital Era, and co-editor-in-chief of the International Journal of Computer-Supported Collaborative Learning. She also serves as a 2020-2021 American Association for Advancement of Science Fellow under the Leshner Institute for Public Engagement with Science, with a focus on public engagement with artificial intelligence, which is particularly timely. She is co-editor of the forthcoming International Handbook of Computer-Supported Collaborative Learning. So shout out for the handbook. Given her deep history of interdisciplinary collaboration, the title of her talk is apropos. It is my very great pleasure to introduce one of our leading scholars in CSCL, Professor Carolyn Rosé, to speak about interdisciplinarity as a core value and a core skill, challenges and opportunities for the field of CSCL.
So thank you so much for inviting me to speak to you today. I'm really excited about this talk. So just to zoom out, I think in this past year, we've all been shaken to the core on many levels with disconnection, with violence, with the strife of all kinds on top of a global pandemic. So clearly the world needs what's at the core of an interdisciplinary spirit, and yet we don't have that. Even on the internet, or maybe even especially on the internet, we are very aware of hate speech and other kinds of very negative behaviors that fight against this spirit. I just want to take a moment to acknowledge one of my PhD students, Chinlan Shen, who's been studying this, because in her research, she's looking at how can we manage these attitudes as they're expressed, especially in counterproductive, violent, and destructive ways. And in particular, she's been looking at Reddit as a platform and using her language technologies abilities to be able to monitor the effects of strategies for managing that. So for example, there originally were bans of subreddits where these behaviors were getting out of control. And then they found that that wasn't working. So they scaled back a bit to sort of lighter punishments like not bans, but quarantines. And some past work had already shown that the quarantines weren't necessarily working from the standpoint of the way that they had been evaluated. But Chinlan took a much deeper look, looking more broadly, not just at subreddits that had been quarantined, but neighboring subreddits where people had moved, and looking at the language from a very deep perspective, applying the lens of some frameworks that can look at different social dimensions of language. And what she found was not only do these quarantines not work in terms of curtailing the behaviors that are a concern, but they also had negative consequences on the side that were unanticipated, which was as people moved around in response to these sort of punishments, there was actually the effect that people of opposing sides were less connected to each other. They were talking less to people who thought differently from them. And we see this more in the neighboring subreddits where people moved. They became more homogeneous and there was less exchange. And clearly the world needs more exchange and not less exchange. And what this teaches us is that maybe punishment, maybe eradicating, maybe taking this negative, opposing stance just isn't working and we need another solution. If we think about what's core to our fields, we work on scaffolding for collaboration. We try to come in with technologies and designs that not punish bad behaviors, but encourage good behaviors. And my question to us as a field is, what do we have to offer in the face of collaborative difficulties of a grand scale, not just, disagreements over why Michael isn't good at math, but, these more emotional issues, these more deeply held beliefs that come up against each other in the world. So if we dial back to the early days of our community, to one of the fathers of our community, Jerry Stahl, he has defined what's very core to our field. The collaboration is primarily conceptualized as a process of shared meaning construction. That the meaning making is not assumed to be an expression of the mental representations of individual participants, but is an interactional achievement. It requires an exchange. It requires achieving an intersubjectivity, which can only come through listening to one another. So what is it that divides us? Well, as I look out at the world, and even more in the past year, I see that what divides us is difference, that humans are fundamentally insecure and afraid of things that are difficult of them. And it's easy for us, I think, as a community that wants to believe that we stand for equity, that we're trying to make a positive difference. But my question to us as a community is there a disciplinary divide, even within our own community, where we want to believe that we value interdisciplinarity? Do we in fact overcome these human tendencies to stay among our own, to not respect what's different from us, to not take the time to listen and try to reach out and try to understand? So again, if we look at our field, we value coming together, we value knowledge integration, and we've worked on a lot of scaffolding for this. We have studies that show that these designs are effective. Our literature is full of the history of our famous, well-known legacies, like the Knowledge Forum that we heard about yesterday. In my own work, I have been investigating in chat environments, students coming together in pairs and small groups, and using intelligent conversational agents to offer that scaffolding. And here you see our first environment, the cycle talk environment, where students work together in thermodynamics. And there we saw the tutorial dialogue agents alongside a human partner can lead a student to learn 1 1.25 letter grades more than an individual student in the same environment doing the same activity, but alone and without support. And since that time, we've worked on in a number of different domains and grade levels, and in all cases, developing the ability to offer context sensitive and interactive support. I want to just take a really quick moment to share with you a video of some of our, what it looks like now, quite different from the past.
Okay, let's go. Did it pass?
You passed a test
cool.
case for the number of lines your program will output. Do you need to know the number of output lines?
What do you think about it? I'm not sure, but I think we need to figure out how many lines do we need.
Yes, otherwise we won't know the format of the output, right?
Yes, it's a diamond, so
Yeah, so we are pretty sure about that we need the number of lines to output.
yes, I'm also pretty sure.
Would you like to discuss this algorithm choice?
Yes.
So you can see that it's come a long way from a chat interface. And this has required us to integrate many different AI technologies with the same core architecture that lets us take the designs that we have learned through the studies that we have conducted over the past 15 years, but to be able to do the listening and sensing through different channels and to offer the support in a multimodal way through gesture and voice and gaze. And even at the core of this, we see the value of listening, the value of being open to multiple perspectives, that these design principles, they look very different on the surface, but all of them are really getting at the same thing, this value of bringing different perspectives together that we believe in or at least say we believe in as a field. And yet, if we ask ourselves the difficult questions, I think that we know that it hasn't always been so smooth, even within our interdisciplinary teams. Let me just take you on a quick trip down memory lane, a little bit about my own career journey. I want to acknowledge my late department head, Jaime Carbonell, who has been rated as one of the top 100 ML researchers. Unfortunately, we lost him to colon cancer just before the pandemic. Not only is he one of the top 100 ML researchers, but his dad, also named Jaime Carbonell, published in 1970, one of the first tutorial dialogue systems, if not the first tutorial dialogue systems. You can see here an example of the kind of conversation that it was able to carry out, even in 1970, the year that I was born, with students. Obviously, the technology has come a long way since then. The Scholar System, that was what it was called in 1970. When I started to do my work, there was already a lot of research on speech and gesture and more robustness in terms of the ability to understand language. Moving further, around 2007 was at the time when we started to take those dialogue agents and use them not for teaching individual students, but to be able to use them as facilitators and sort of catalysts in human-human interaction. And finally, as the field of multimodal interaction has taken off in the past decade, we can do what you saw in the video. Now, all of this required being in touch with the evolution of the field of AI. It required going back and forth, that there was advances on both sides. There was design and investigation on the side of CSCL for designs of scaffolding. There was independently research in AI on multiple different AI technologies for the sensing, identifying faces, understanding the speech, looking at the distance between people or the positioning of people, being able to gesture at them. Initially, these technologies, as they arose, they, on the one hand, inspired a lot of hype, on the other hand, a lot of fear, neither of which are very productive. And there would be attitudes, some people thinking this was going to change the face of education, and others thinking that it was completely worthless, that it wasn't going to change anything at all. But in my own path, there was an interaction between these two fields. That interdisciplinary spirit is very much at the core of artificial intelligence. I think many people tend to think of artificial intelligence as just computer science. It's just about algorithms. It's that other field out there. And yet, two fathers of the field of artificial intelligence, Herb Simon and Alan Newell, were deeply interdisciplinary. Herb Simon was an American political scientist, an economist, a sociologist, a psychologist, and a professor. He was in our psychology department at Carnegie Mellon. He won a Turing Award, a Nobel Prize in economics and the National Medal for Science. Alan Newell, his collaborator in the School of Computer Science, also had a joint appointment with the Business School and the Department of Psychology and was also a Turing Award winner. So these fathers of artificial intelligence were by no means sitting alone in their office with their pocket protectors, just writing code. They were boundary spanners. And as all great boundary spanners, they had to deal with a lot of strife, whatever issues there were between sub-communities. If you're a boundary spanner, you are going to get the brunt of it. But they stood up to that, and they did their great work, and we appreciate them for that. If we come back to what do we know that would support such boundary spanning behaviors within fields, within communities, we come to a construct that's been very important in my research called transactivity. This is about people listening to one another, feeling safe enough to articulate their reasoning and to do it in a way that reaches back and builds on or extends or challenges the reasoning of another. And we have many results in our field that point to this as a mediating or moderating process variable for expertise sharing, collaborative product quality, and learning. At its core, it's about building the connection between ideas, but it's predicated on more basic processes of deep listening, comparing of mental models, and sharing of insights that are in turn predicated upon respect and interest and self-efficacy. And in its effect leads to increased learning, expertise transfer, group task success, and a sense of shared decision-making that's also important. In our work modeling collaborative interactions, we've looked at multiple levels, and what's interesting is to see how, even in looking at the interplay between those data levels, we can see how these layers build on and synergize with one another. So in an earlier study, we were looking at a speech signal from dyads in terms of a socio-linguistic construct called speech style accommodation, which signals a desire to build common ground and to de-emphasize differences that would signify kind of social disconnection. And so it's not just removing difference, but it's about de-emphasizing those things in our social identities that might set us apart from one another. And that's why it's a signal that somebody wants to build common ground. On the other side, another student from a learning sciences perspective looked at the transcripts from the same conversations and annotated them for transactivity. And then we looked to see how those variables correlated with one another. And as we saw ranked conversations in terms of how much evidence of speech style accommodation we saw over time, we also saw an increase in the concentration of other oriented transacts within our value of 0.4. So we see a relationship between these levels, where on the one side, we see just a style indicator, has nothing to do with what's being said, but signals that attitude, that it correlates with something about the content and how it comes together. Because when we behave in a transactive way, it's growing out of something deeper within us. We can turn it on its ear too. Some of you have heard about some of my past work where what we've done in massive open online courses is invited students to take their individual work and present it to the whole class community in a discussion forum. And as we invited students to pick other students to offer feedback to, and then as we automatically evaluated that feedback for transactivity, we used our measure of transactivity exchanged between students to be able to assign students to teams. Note that this is a partition of a classroom and not a way of preferring to match students who are just better and more articulate at argumentation. So what we did was to maximize the extent to which, as we grouped that whole class into groups of 4, that students were together in teams with other students they had that level of synergy with in the whole class discussion forum. And then we looked at how they did in a small group assigned that way in comparison to small groups assigned randomly. We did this in simulated classes as a lab study so that we could run the class multiple times and compare the different ways of partitioning. And what we found is that within those groups, that if we compare groups in classes where they were randomly assigned to classes where they were assigned based on transactivity, that the transactivity of the interaction within the small group was higher when we used transactivity as the basis for the assignment. And so we see that the observed transactivity is not just something that happened at that moment, but it says something about the collaboration potential between those people. We also saw that their group product was more integrated. So these things show the connection between these. But what is this kind of scaffolding that might be able to address building up those core attitudes in places where it's challenging, where it's difficult? Well, some of our recent work has focused at the adult learning level in software development teams. And we're starting to do this work in classrooms with the goal eventually of being able to support collaboration in the workplace. Some of our work is at Carnegie Mellon, but more exciting than that is how we're partnering with community colleges in order to offer a different version of the content, but as part of community college IT programs that take low-income, underemployed individuals and give them a way to get certifications to a really good, much better paid kind of position as, say, a cloud administrator. And obviously, I mean cloud as in, computer storage cloud. So in any case, what we've been doing is looking at how we can take an industry standard paradigm for collaborative software development and use it to support collaborative learning. And this paradigm is called mob programming. You may have seen my student Srichar and Sankaranarayanan presenting some of our work earlier today. In this work, it's all about online collaboration. So similar to some of our past work, we're using an online collaboration environment, this time collaborative software development. Here you see AWS Cloud9. We're also working in Microsoft VS Code Live Share. Both of these are collaborative software developments environments used in industry. So as we learn how to support collaboration in these environments in classrooms, we're preparing to be able to do similar support in the workplace where people continue to use these environments. You can see our chat environment over on the side, and this OPE bot is the conversational agent that's managing this mob programming paradigm. Normally what happens, you already saw, is that mob programming happens in face-to-face collaboration. And we can support face-to-face collaboration as well, as you saw in the video earlier. But it actually, it works very well in a large class like this cloud computing course with usually about 150 students in a semester to do it as a fully online course. And there's also an awful lot of a collaborative software development in industry also that happens in these online environments, which is why they exist in the first place. This mob programming paradigm is designed to be able to support differences in groups where there are a set of roles. We have 4 roles. This is a slightly modified version of mob programming from the industry standard. We have kept the driver and navigator roles that you'll also remember from pair programming. The driver is the only one in the group directly entering the software into an editor. The navigator is leading a discussion with the group and directing the problem-solving path. In some ways, the navigator is doing more of the cognitive work of the programming than even the driver, who's the one who's entering it and doing sort of more low-level implementation. We also have a researcher role who brings in resources to the discussion to support reflection and consideration of alternative solution paths, and someone who we call the project manager, who's kind of evaluating the extent to which people are taking up their roles and offering feedback on the role taking over time. When we use mob programming, the roles rotate, and the goal is to allow people to view their partners from different perspectives as much as they're bringing their own perspective in, so that they may be frustrated at a certain point in the problem solving because they see someone as being deficient in the role that they're playing, but later they realize that that person shines in another role and they learn to appreciate them. And we have heard students already talking about this as an effect of this role-based setup. So one of the things that our bot does is to manage the time of the interaction, to divide up the collaborative time that the students have into phases. And in each phase, as you're entering the phase, the roles rotate so that throughout, by the time they get to the end of the activity, everyone has played every one of these roles. But the agent is also supporting the processes while they're going on during the problem solving, as we have done in our previous studies. Lately, what we've been looking at is how the actual programming task, the actual involvement in the software development trades off with just taking time out from actually pushing towards productivity and just formally taking time as a group to reflect on alternative solution paths. And in computer science education, there's a very strongly held belief that students are really only learning when they're actually writing software, that writing software is such an important part of any serious computer science class. And so we wanted to see, though, what would come from introducing reflection and how should it be interleaved with the problem solving? Could we leverage the long history of research in problem solving, looking at how worked examples, for example, in problem solving trade off with each other at different stages of expertise? One thing we see is that there's much more transactive knowledge integration that occurs while the students are reflecting together. And so we feel that that's an important place for building this connection. And we want to be able to take that into the workplace as well, where there are real conflicts that come from much more being at stake in that environment in terms of people's own earning potential, career path, evaluation, keeping their job, maintaining their interpersonal relationships with people who they're with when they're tired, when they're stressed out, day after weary day. In that environment, will the kind of support that has worked in a classroom have any kind of positive effect on the collaboration? We are still working towards an answer to that question. Just to offer sort of a set of results from one of our recent studies, different from the one that Sricharan talked about earlier today. In this particular study, we were investigating a 2x3 factorial design where we alternated within each of 4 phases, either ordering programming before reflection or reflection before programming. And then we looked at 3 different temporal breakdowns, spending a third of the time before the switch, 50% of the time before the switch, or 66% of the time before the switch. And we looked at pre to post test learning of conceptual knowledge about the programming between pre and post around the collaborative activity. But then after that activity, the students go off and they do a much more substantial, individual, much more advanced programming task by themselves. And we also looked at how the students would do on that task. And we came into it, with our colleagues being strongly believing that the students may or may not learn more if they reflected more when we were just looking at that test, but they certainly would be less prepared for the programming part if they had spent less actual time programming. What we found is actually, based on pre-post test results, that students learned more when more of their time was spent in reflection. In this particular study, it didn't matter which one they did first. The results that Sricharan presented earlier today were from a different unit, and I think that we did see differences there in terms of the ordering. There was no significant difference in terms of how well the students performed in the programming, which you might say, well, that doesn't prove anything just because you didn't find a significant difference. But in fact, the trend was in the opposite direction. The trend was that students who reflected more actually programmed better. So if nothing else, they at least certainly didn't lose. And this really challenges even what we know about teaching computer science and encourages us to continue pushing for what would encourage more on-the-job learning, and how can we use supported collaboration to address some of these relational issues. You'll notice I can't say we have any results on that front yet. So we're not done yet. There's a lot more work to be done in order to be able to create the environment in which we find that people have more of a natural tendency to interact with each other in the way that we would like to see. Zooming slightly out and looking again at us as a community, have we learned anything that allows us to approach the problem of repairing the disciplinary divide that we see? And then if we could at least do that, maybe we would have something to say for the larger problems in the world that we see. I think we first have to ask ourselves a question. What are we doing in our research that even gets at this? What is interdisciplinarity anyway? Well, we talk about it in multiple senses. We talk about teams being interdisciplinary if they involve people with different expertise. We talk about work showing evidence of interdisciplinary involvement if it's benefited from the expertise that people bring in. So it could be a property of the work product or of the work that was required to build that product. It could be a property of a thinking process, that the knowledge integration that we go for and study and look for in collaborative processes, that is the core of interdisciplinary. But that interdisciplinarity, I would argue, is the experience of interdisciplinarity. But does it tell us about what allows it to happen? You could also, and it very frequently is the case, that we talk about interdisciplinarity as a property of a course, that it allows people to learn about multiple disciplines, or a degree program if students are required to take courses in multiple disciplines. But what do we know about the skills in an individual that allows them to be interdisciplinary people? Not just to achieve expertise in multiple fields, but to be the kind of person who can behave in an interdisciplinary team in an appropriate way. Well, there has been some work in the field of engineering education to be able to operationalize what it means to have this interdisciplinarity skill. Because it was important in the field of engineering to be able to assess the extent to which programs were training people to be interdisciplinary engineers, to be able to have the skills that they would need in order to work in teams where they would be working with people of other fields. And even they would argue that they are dissatisfied with the instrument that they developed, which was a self-report questionnaire. Although the published research from 2012 shows that it shows reliability even in being a self-report questionnaire, nevertheless, there's the sense that we'd like to have something more rigorous than that somehow, if it was possible. They operationalize interdisciplinary competence as combining students' perceived understanding of existing disciplines with their assessments of their ability to work across disciplines, both within and outside the field of engineering. And having this kind of starting place of an assessment, I literally combed the literature looking for other actual assessments of a person's ability to behave in an interdisciplinary way, and I didn't find anything. Although there are instruments that seem related to this, and I'm happy to discuss that. But in terms of like squarely focusing on interdisciplinarity as a skill, this was the best that I found, and even the people who designed the instrument are dissatisfied with it. I think it's a starting place though. And it was used as part of a long investigation into how engineering education programs might foster that skill in people. And in this research, what they found was properties of programs that encouraged development of the skill included exposure to differences, so participation in non-engineering clubs and activities, study abroad opportunities, and humanitarian engineering projects. And also, it was those programs that really worked hard to foster a culture of openness, with a curricular emphasis on broad and systems perspectives, and valuing and rewarding skills related to interdisciplinarity. They measured in effect of this as they evaluated across programs across the United States to see how they differed in terms of the extent to which they did these things and how they saw students gaining in this skill when they controlled for numerous other factors. I'm not going to go into great and gory detail, but the publications are there. So we can start here. But I think that we have a lot of work to do to move into a space where we actually are learning in a rigorous way, what can we do in our field to develop scaffolding that actually is having a lasting effect on this interdisciplinarity of attitude. If we can do that, can we then change ourselves? Can we then make our own community more open and welcoming and interdisciplinary? And when we do that, will we be an example for the world to address these larger issues? I'm excited to be able to say that I am hoping to get a collaboration off the ground with Kylie Pepler and Melissa Orta Martinez that is an interdisciplinary project. Our goal, in fact, is to investigate this issue of interdisciplinarity. This project, we have gotten the good news, has been recommended for funding, and so we're crossing our fingers to hope that we'll be able to do this. But we're bringing together computer science, weaving, and robotics in order to create an interdisciplinary experience in which we can inject designs for supporting collaboration and to be able to trace the development of interdisciplinarity as a skill, as a starting place. We're building on all of our past work in all of these areas, but we have a long way to go. But our hope is that we'll learn things that not only will offer something to education, but can change us as a field and can contribute towards the world. And let me just acknowledge this work will bridge the seemingly remote worlds of robotics and textiles. They look very different. They're considered very gendered. They offer the opportunity to address some issues in broadening participation in computer science. They emphasize the common foundation in math, which actually, at least maybe my computer science colleagues or anyone who's taken linear algebra will recognize that what we see here in this weaving draft is that the cloth design is an emergent property from the multiplication of three matrices, the threading, the tie-up, and the treatling. And so we can really use this opportunity to engage students in matrix math and to help them to see the connection with software as a bridge between the worlds of robotics, which is going to give us our robo-loom. We're very excited about that. And the textiles that students will design and create together. So this will engage students in math and computational thinking, leveraging software as a tangible and functional bridge. And I'm so excited about this collaboration because, as some people who know me know, my secret hobby is weaving and I love it. So it's a good excuse. Zooming out, what does that mean for our society? It's been my long-term dream to create bridges that get us out of our own little pods. And so some might remember that during my presidency, my project was to build community among the various different learning sciences societies, where we started to talk together about what was similar and different about what we were doing and to ask ourselves, why do we have so many different societies? Why are we so fragmented in the first place? Well, we didn't decide to erase those differences. We decided instead to value each of our societies as puzzle pieces and to think about what is the puzzle that we could bring together. And that has become the International Alliance to Advance Learning in a Digital Era. And since its inception, we have been sort of fostering kind of inward communication among these societies in terms of having paper exchanges. So best paper award winners from any of these alliance societies can present their work in one of the sister societies in the year after they get their award. And now that that's kind of off the ground, we are turning more towards our outward goal. That was always our objective, that as a unified set of societies, we might be able to more effectively channel the storehouse of knowledge that has come out of our research to make it more accessible to end users of that. And so in recent work, we organized a workshop, some of you are aware of that, where we did a matchmaking between researchers from the 10 different societies in 3 different areas with audience members who came from all sectors, including researchers, but also policy people, teachers, school administrators, people who have companies that are developers. We didn't have as many of these people as probably ideal. It was a little bit out of balance, and yet we came out of it learning some things. You can see an AI Matters column that has been published about that also advertises that there will be a webinar coming up on the 24th, where I'll share a lot about what it is that we learned from this experience. We adopted the metaphor of a mycelium in this, because a mycelium teaches us that you can have organisms that look very disconnected and long distance from one another, and yet underlyingly there's a network that connects them, and that they don't have to operate as competing kingdoms, as it were, trying to dominate one another, but that they can come together in an ecosystem that supports one another and works together more effectively. And I just want to acknowledge my daughter, Rachel. She's a mycologist. She was the inspiration for this metaphor, and I love her very much. And I haven't seen her in 1.5 years, but I'll see her tomorrow, and I'm so excited about that. Anyhow, where does that leave us as a field? Well, I think that we have questions that we haven't answered yet about interdisciplinarity. We work on knowledge building, we have scaffolding, we've had success, we've looked at lots of related things, we've talked about interdisciplinarity, and yet we have our own breakdowns with it. And yet we haven't seen or tested our scaffolding in the really, really hard places where we see disconnection, where we see breakdown in the world today. And so I think that we have a lot of work to do as a field in terms of beefing up our ability to measure interdisciplinarity as a skill, to scaffold it, and to foster growth. And I encourage our field to think beyond the sphere of education and training, to think about this interdisciplinarity personally as human beings, in our learning settings, yes, but in our societies more broadly, and even globally in the world. So thank you so much for giving me this opportunity. And now I will very much welcome any questions you might have.